Good morning, my lovely kiddos. Welcome to 6.3, where we're talking about medians and centroids and triangles. So we're talking about medians, centroids, and the centroid theorem today. So let's go ahead and dive right into our definition. Okay, so a median of a triangle is the segment formed by connecting a vertex or a point, like an angle, to the midpoint of the opposite side. And remember, opposite means that it's a side that our angle does not touch. So let's draw a quick example here. I'm going to go ahead and draw just a triangle. And I'm going to label our points A, B, and C. Okay, so a median would come out of one of the points or our vertex. I'm going to choose B here, and it is going to cut through the triangle and touch the opposite side. So you can see that B does not touch our side AC, so they are opposites. Okay, so I'm going to go ahead and connect that line. Now this median is going to be the midpoint of our opposite side, so AC. So it is going to cut AC in half. So A to this mystery point here is congruent to from the mystery point to C. So these two halves of AC are congruent. So the midpoint, or the median, my apologies, is what starts at an angle or a vertex and goes to the opposite sides and form a midpoint. Okay? The centroid is a point where all three medians intersect inside of a triangle. Okay, so let's go ahead and draw that picture as well. So I'm going to draw the exact same triangle here with the same names. We have A, B, and C. We already had one median starting at the vertex B, cutting across and having A to this mystery point and this mystery point to C congruent, these two sides congruent. Okay, so now let's do one for C. It starts at C, it's going to cut across the triangle and cut AB into two congruent pieces. I'm going to give these tick marks because they are congruent to each other, but not congruent to these two on AC. And finally, we're going to have one come out of vertex A and then cut CB into two congruent pieces. And these are going to get three tick marks, again, because they are congruent to each other, but not congruent to the rest. Now the centroid is going to be this point right in the middle where all three medians touch. All right, and of course we have a theorem for this. The centroid theorem says that the centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, so let's go ahead and draw a picture so that we can see what that means. Okay, so I'm going to draw the exact same picture here, the same triangle, points A, B, and C. Okay, so we are going to go ahead and draw these medians in as well. So it's the same picture from right above here. Okay, so we have our centroid right here in the middle. I'm going to give this the letter P. So I'm going to name this P. And then I'm going to name these points that are our new midpoints, just G, F, and E. Okay, so we have a little formula here. So from the vertex to the centroid, I'm going to start with A, P. So from the vertex to the centroid, that is equal to 2/3 of the whole thing. So from vertex to the midpoint, A, E. Okay, let's keep going. Let's go to C here. So C, the vertex, to P, the centroid, is equal to 2/3 of the whole thing, C to F. And our final equation here, our vertex B to the centroid P, so BP is equal to 2/3 of that whole thing, B to G. Okay, we can find the lengths of the segments for our medians by cutting our medians into two pieces. We can divide it into vertex to centroid and then centroid to midpoint. So we have two pieces of each median here. One of these pieces, like I just said, is the vertex to the centroid. So C to P, A to P, B to P. Okay, all listed right here. And the second piece, or one piece, will be from the vertex to the midpoint, so the whole thing. Okay. Let's do some examples here. So we can see that BE and ED, we are trying to find BE and ED. Okay, so from vertex to centroid, B to E, and then centroid to midpoint. And we know the whole thing, BD, is equal to 24. So we're going to set up those equations. Okay, so from vertex to centroid, BE is equal to 2/3 of the whole thing, B to D. Those are the same equations that we just set up with the centroid theorem here. So vertex to centroid is equal to 2/3 of the whole thing. All right, now we know what the whole thing is. We know what BD is. That's 24. So we're going to plug in 24 in place of BD here. So I'm going to rewrite my equation. BE is equal to 2/3. And then instead of writing BD, I'm going to go ahead and write what we know BD to be, which is 24. Okay, if we plug this into a calculator or do our little fraction shortcut, multiply 24 by 2, and then divide that number by 3, we find that BE is equal to 16 units, because we don't know if these are inches, miles, centimeters, whatever. Okay, so we found BE, but we also want to find ED, so we want to find from the centroid to the midpoint. Well, if we know that vertex to centroid is 16, and we know the whole thing is 24, we can set up an equation that is very similar to the segment addition postulate from way back in chapter 1. Okay, so that's where we take BE, the first chunk, vertex to centroid, and add it to our second chunk, centroid to midpoint, ED, and that is equal to the whole thing, vertex to midpoint, BD. Okay, now we're going to plug in what we know. We just found out that BE is 16 units. We don't know what ED is, so that's what we're trying to solve for. And the problem told us that BD was 24. Okay, from here it's just solving like an algebra 1 equation. So in order to get ED by itself, we're going to have to do the opposite operation to this positive 16. So we are going to subtract 16 once on each side of the equal sign. Plus 16 minus 16, those are going to cancel, leaving us with just whatever the segment ED is. And 24 minus 16 is 8. So ED is equal to 8, so we found BE and ED. All right, let's do another one. So here we are trying to find PQ and PN. Okay, so that is, we're looking at this opposite now. We're looking for midpoint to centroid, and then centroid to, and then the whole thing. PN is the whole thing. So we know that QN, or vertex to centroid, is 20. Okay, so we're going to set it up like that. So vertex to centroid, NQ, or QN, it's the same thing, is equal to 2/3 of the whole thing, NP, or PN, which is one thing that we're trying to find here. Okay, so our second step here is to plug in what we know. We know that QN, or NQ, is 20. So we're going to plug in 20 here is equal to 2/3 of NP, which we don't know what that is. Okay, in order to get NP, we want to get that variable alone. So since we are multiplying by 2/3, we're going to have to divide by 2/3. But when we divide by fractions, we're really multiplying by the reciprocal. Okay, so we are multiplying each side of the equal sign by 3/2. We flip it, that's reciprocal. Okay, multiplying reciprocals, those make those cancel and they go to 1. So we are just left with NP or PN. And then using our fraction trick, 3 times 20 is 60. 60 divided by 2 is 30. We could also just plug that into the calculator. So we found NP or PN to be 30. And now we're going to find PQ by setting up that segment addition postulate piece. Okay, so first chunk, vertex to centroid, NQ, plus centroid to midpoint, QP, is equal to the whole thing, vertex to centroid, NP. And now we plug in what we know. The problem told us that QN or NQ, we're allowed to flip those letters, was 20 plus whatever QP is, because we are still looking for PQ or QP, we're allowed to switch the letters. And then we just solved NP to be 30. Okay, so we're just solving this like an Algebra 1 problem. In order to find QP, we need to use the opposite operation on this positive 20. So we're going to subtract 20 from once on each side of the equal sign here. Positive 20 minus 20, those are going to cancel because they add to 0, leaving us with just QP. And then 30 minus 20 is 10. Okay, so we found PQ and PN as well. Let's do another one. Here we are trying to find JG and KG. All right, so here we are trying to find JG, which is the midpoint all the way to the vertex passing through the centroid. And then we're also trying to find KG, which is the vertex to the centroid. So here we're going to have to use our brains a little bit more, where it's not just plug it into a formula and chug right on through. So let's brainstorm. If the vertex to the centroid is 2/3 of the entire length, which is what these equations that we've been setting up says, that means that the remaining 1/3 is kept between the centroid and the midpoint. Okay, we know from the problem that JK, centroid to the midpoint, is 4 units. So we're going to set up another equation here, and that is that JK, centroid to midpoint, is equal to 1/3 of the entire length of JG. Okay, we know that JK is 4. And then I'm just copying down the rest of this equation here. And then just like the previous problem, we are going to have to divide by this fraction. And when we divide by a fraction, we are actually multiplying by its reciprocal. So we are multiplying both sides by 3/1. Okay, 1/3 and 3/1, those cancel because they go to 1, leaving us with just JG. And 3 times 4 is 12, divided by 1 is still 12. Or you could just plug that into a calculator as well. So now we know that the whole segment J to G is 12 units, so we can cross off our first unknown. Now we're going to plug in our 2/3 equation to find the KG, or vertex to centroid here. So we have KG, centroid to midpoint, or centroid to vertex, my apologies, is equal to 2/3 of the entire thing, JG. Now we just solved JG to be 12, so we're going to copy this equation down and write 12 in place of JG. Now using our fraction trick, 12 times 2 is 24, divided by 3 is 8. Or you could just plug that into a calculator as well. So JG is equal to 8. KG is equal to 8. My apologies. Okay, that was a tough one, having to come up with another equation where we know that 2/3 and 1/3 add together to 3/3 or 1/2. Okay, let's do another one here. Okay, so E is our centroid of this triangle ABC, and B to E is 12, so vertex to centroid is 12. And we want to find BD, which is the entire length, and ED, which is the 1/3 or centroid to midpoint. Okay, so we're going to set up our 2/3 equation here. So we have vertex to centroid, or BE, is equal to 2/3 of the entire segment, BD. Now we know that BE is 12 units, so I'm just copying down the rest of the equation after I plug in 12 for BE. And just like before, we are going to have to divide by 2/3, but when we divide by a fraction, we're really multiplying by its reciprocal of 3/2. Okay, 2/3 times 3/2, those go to 1, so they cancel out, leaving us with BD. And then using our fraction trick, 12 times 3 divided by 2, and that is going to give us 18. So 18 units. BD is 18 units, the whole thing. Now here to find E to D, or centroid to midpoint, we could either set up another 1/3 equation, or we could do like we did in the previous problems and set up a segment addition postulate type thing. I'm going to set up a segment addition postulate. Okay, so we have vertex to centroid, or BE, plus centroid to midpoint, ED, is equal to the whole thing, vertex to midpoint, BD, and then plug in what we know. We know BE is 12 plus whatever ED is, and then BD, the whole thing we just solved to be 18. Now we'll just have to solve this like an algebra 1 problem here, do the opposite operation of this positive 12. So we're going to subtract 12 once from each side of the equal sign. Positive 12 minus 12, those are going to cancel, just leaving us with ED, and 18 minus 12 is 6. Okay, so we found our two missing pieces. Now we're going to move on to the very last problem on our worksheet here. So T is the centroid of triangle PQR. PS, so the whole segment here, P to S, vertex to midpoint, is 33. We want to find both pieces. So vertex to centroid and centroid to midpoint. We can either set up the 2/3 and the 1/3 equation, or we could do 2/3 and then the segment addition postulate as well. Okay, I'm going to start with the 2/3. So vertex P to centroid T is equal to 2/3 of the whole thing, vertex to midpoint PS. Now we're going to plug in what we know. So I'm just copying down this equation and then plugging in 33 in place of PS because the problem told us that it was 33. Okay, either plugging this into a calculator or 33 times 2 divided by 3. That's going to give us that PT is equal to 22. Okay, from here we can either do our 1/3 equation and say that centroid to midpoint TS is equal to 1/3 of the entire PS segment, or we could just do our segment addition postulate. I'm going to do since I did the segment addition postulate on the last one, I'll go ahead and do the 1/3 equation one more time. So centroid to midpoint, T to S, is equal to 1/3 of our entire segment, P to S. Okay, so we know that PS is 33, so I'm going to copy down the whole equation and then plug in 33 for PS. Okay, either plugging into a calculator or using our trick of 33 times our numerator of 1, which is still 33, divided by 3, we get that TS is equal to 11. Okay, so I'll show you guys all the examples again. And let me know if you guys have any questions.